Hello, ma'am. Hello, everyone. So we are now in lecture 6, is mirror and lenses. So for problem set number 1, example 2.1, solar electric generating system. So in this problem, so we're going to find the first, if we want the rays from the sun to focus at 40 cm from the mirror, what is the radius of the mirror? Second, what is the amount of sunlight concentrated onto pipe per meter of pipe length, assuming the insulation incident solar radiation is 900 watt per meter squared. And last, if the fluid carrying pipe has a 2 cm diameter, what is the temperature increase of the fluid per meter of pipe over a period of 1 minute? Assume that all the solar radiation incident on the reflector is absorbed by the pipe and that the fluid is mineral oil. So, um, first, identify the physical principles involved. So, in letter A, um, related to the optics of the spherical mirror. So, the sun is the sun is the object. So, the object distance is essentially infinite since layo na siya kayo. So, the distance of the object is infinite. The desired image distance is 40 cm. So, we use the mirror equation to find the focal length of the mirror. So, 1 divided divided by the distance of object plus 1 over distance of image is equals to 1 over the focal length. So by deriving this equation, we found this focal length is equals to 1 over um, d sub o plus 1 over d sub I raised to negative 1. So substitute the value. So first, the distance of the object, which is the object is the sun, which is the infinity, and the distance of the image is 40 centimeter. So the answer is 40 cm. But in letter A, what are we trying to find is the radius of the mirror. So to find the radius of the mirror, we're going to multiply the focal length to 2. So radius is twice the focal length. So the answer, or the radius of the mirror, is equals to 80 centimeter. Next, for letter B, it involves a little math, primarily geometry. So the insulation is 900 watt meter squared. You must find the cross-sectional area of the concave mirror. Since the power delivered is 900 watt per meter squared times the cross-sectional area, the mirror in this case is quarter section of a cylinder. So the area of a focal length of the mirror is 1/4 times 2 pi r times length. So the area for a length of 1 meter is then area is equals to pi over 2 times r times 1 meter is equals to 3.14 divided by 2 times 0.800 meter times 1 meter is equals to 1.26 meters squared. So that's the cross-sectional area. So now the insulation on the 1 meter length of pipe is then 9 times 10 raised to 2 watt per meter squared times 1.26 meters squared is equals to 1130 watt. So for letter C, it requires an understanding of heat and density. So the increase in temperature is given by Q is equals to mc times delta T. So the mass of the mineral oil in the 1 meter section of pipe is m times the density of density times the times m. So density times pi times d over 2 squared times 1 meter. Substitute the value. So the density is equals to 8 times 10 raised to 2 kilogram per meter cube times the pi, which is 3.14. Then the d over 2 is equals to 0.0100 meter squared and times 1 meter. So the answer would be 0.251 kilogram. Therefore, the increase in temperature in 1 minute is 1130 watts times 60 seconds. The 1 minute is equals to 60 seconds. over 0.251 kilogram times 1670 joule kilogram per degree Celsius. So the temperature in 1 minute is 162 degrees Celsius. So for problem set 2, example 2.2, imagine a convex mirror. So in this problem, the given or the the distance of the object, which is 12 cm, and the magnification, which is 0.032, and we're going to find the radius. The radius. So if you find the focal length of the convex mirror formed by the cornea, then you know its radius of the curvature. It's twice the focal length. So the object distance is 12 cm and the magnification is 0.032. So first find the image distance and then solve for the focal length. So starts with the equation for magnification. So magnification is equals to distance of image divided by the distance of object. So solving for the di and inserting the given value yields. So the given value yields. So distance of image equals to negative m times d sub o, or negative of magnification times the distance of object. So the magnification is equals to 0.032 times the distance of object, which is 12 cm. So the answer, or the distance of image, is equals to negative 0.384 centimeter, where we retain an extra significant figure because this is an intermediate step in the calculation. Solve the mirror equation for the focal length and insert the known values for the object and image distances. So solving for the focal length, diba, same lang siya sa previous example. So focal length is equals to 1 over distance of object plus 1 over distance of image raised to negative 1. So substitute the value of distance of object and distance of image. D sub O is equals to 12 cm and D sub I is equals to negative 0.384. So the focal length is equals to negative 0.40 centimeter. And again, the radius is twice the focal length. So to solve the radius of the curvature, so we're going to multiply the focal length to 2. So the answer, or the radius of the curvature, is equals to negative 0.80 centimeter. Problem set number 3, example 2.3, using lenses maker's equation. Find the radius of curvature of the bincomplete lens symmetrically ground from a glass with index of refractive 1.55 so that its focal length in air is 20 cm. For a bincomplete lens, both surfaces have the same radius of curvature. So in this problem, the given are the focal length, which is 20 cm, and the refractive in 1.55, and we're going to find for the radius of curvature. So use the thin lens form of the lens maker's equation. So 1 over the focal length is equals to n sub 2 divided by n sub 1 minus 1 times 1 over r sub 1 minus 1 over r sub 2. So where r sub 1 is less than 0 and r sub 2 is greater than 0. Since we are making a symmetric bincove lens, we have absolute value of r1 is equals to absolute value of r2. So we can determine the radius of curvature from 1 over focal length is equals to n sub 2 divided by n sub 1 minus 1 times negative 2 over r. So solving for r and inserting the value of the focal length is negative 20 centimeter, and n sub 2 is 1.55 and n sub 1 is equals to 1, gives us this r is equals to negative 2 f times n sub 2 over n sub 1 minus 1 is equals to negative 2 times negative 20 centimeter times 1.55 over 1 minus 1. So our radius of curvature is equals to 22 centimeter. Problem set 4, example 2.4. Converging lens in different object distances. Find the location, orientation, and magnification of the image for an 3 centimeter high object at each of the following position in front of convex lens of focal length 10 centimeter. So A. So distance of object is equals to 50 centimeter. So for B, distance of object is equals to 5 centimeter. And for letter C, distance of object is equals to 20 centimeter. So let's solve first for the letter A. For distance of object is equals to 50 centimeter and the focal length is positive 10. So to find the distance of image. Distance of image equals to 1 over f minus 1 over the distance of object raised to negative 1. So substitute the value. Focal length is 10 and the distance of object is 50 centimeter. So the distance of image is equals to 12.5 centimeter. So the image in positive, so the image is real, is on the opposite side of the lens from the object and is 12.6 centimeter from the lens. To find the magnification and orientation of the image, use magnification is equals to distance of image divided by distance of object. Since we obtained the value of distance of image, so we can calculate now for the magnification. So magnification is equals to negative d sub I over d sub O. So substitute the value. Negative 12.5 centimeter divided by 50 centimeter is equals to the magnification is equal to negative 0.250. The negative magnification means that the image is inverted. Since the absolute value of the magnification is less than 1, the image is smaller than the object. The size of the image is given by the height of the image is equals to the absolute value of magnification times the height of the object. So the value of the magnification is 0.250 times the height of the object, which is 3. So the answer is equals to 0.75 centimeter. So now for letter B, distance of object is 5 centimeter and the focal length is positive 10 centimeter. So same process. So di, let's substitute the value of focal length, which is 10 cm, and for the distance of object is 5 centimeter. So the distance of image is equal to negative 10 centimeter. The image distance is negative, so the image is virtual. It's on the same side of the lens as the object and is 10 centimeter from the lens. The magnification and the orientation are found to form. So again, for magnification, same process ng gihapon. So negative magnification is equals to negative d sub I over d sub O. So substitute the value. D sub I is equals to negative 10 centimeter and d sub O is equals to 5 centimeter. So the magnification is positive 2. The positive magnification means that the image is upright. It has the same orientation as the object. Since the absolute value of magnification is greater than 0, the image is larger than the object. The size of the image is, again, the size of the image, same nagyapon siya sa previous. So we're going to multiply it, the magnification to the height of the object. So 2 times 3 cm is equals to 6 centimeter. And letter C, for distance of object 20 centimeter and focal length positive 10. So again, same process. Distance of image, so substitute the value of the focal length 10 cm and the value of the distance of the object, which is 20 cm. So the distance of image is equals to 20 centimeter. So the image distance is positive, so the image is real. It's on the opposite side of the lens from the object and is 20 centimeter from the lens. So the magnification is the value of the distance of object image is 20 centimeter and the distance of object is 20 centimeter. So the answer, the magnification is negative 1. The negative magnification means that the image is inverted, and since the magnification is The absolute value of magnification is equals to 1. The image is same size as the object. Since the magnification is 1, we're going to multiply it to the to the height of the object, which is 3. So same na sila ng size. Problem set number 5, example 2.5. Choosing the focal length and type of lens. So in this problem, the given are the figure 2.28, and the distance of image is equals to 1.5 meters. The distance of object is 0.75 meters, and the focal length is 0.50 meter. So in this problem, we're going to find the magnification. The image must be real, so you choose to use converging lens. The focal length can be found by using the thin lens equation and solving for the focal length. The object distance is 0.75 meters and the image distance is 1.5 meters. So solve the thin lens for the focal length and insert the desired object and image distances. So to solve the focal length again, 1 over distance of object plus 1 over distance of image raised to negative 1. So substitute the value of DO and DI. So D sub O is 0.75 meters and D sub I is 1.5 meters. So the focal length is equals to 0.50 meters. And the magnification is equals to distance of image divided by distance of object. So negative distance of image divided by distance of object. So substitute the value, negative 1.5 meters divided by 0.75 meters. The magnification is negative 2.0.